Yeah, hello. So before we can get started, I actually have to finish something real quick. Sorry for that. So let's do this. It's just a line, trust me. So equals this and save it. Okay, should be fine. Let's just start the tests real quick to make sure everything works still. Okay, this will take a while. So I guess, I guess we have time now. So for this talk. This talk is, like Jess already said, it's about testing tools. In particular about Vitest and Cypress. But it's not only, or it's not the main point of the talk which tool you should use, but rather when you should use which tools and how you can make sure to always use the best tool for the job. This is me. I think. Hello. Okay, let's do it this way. So I guess this video was too much for the microphone. So let's do it this way. As you can see here, I know a thing or two about tools. This is me with a sledgehammer, having a lot of fun renovating my house the last couple of years. And one thing I learned is that in regards to tools, it's important to have the right tools. Because if you have a poor tool or you have used no tools at all, the same task can take a much longer time to accomplish, actually. And it's the same when it comes to programming and especially when it comes to testing. So as you can see here, for testing, we also have a lot of tools. We have Cypress, for example, we have Playwright, we have Vitest, and a couple of other tools. And what I think is important to know about the strengths and weaknesses of all those particular tools and when to use which tool to accomplish a particular task or in which use case we want to use a particular tool. But what is important when it comes to choosing the best testing tool for the job? So in my opinion, at least, the most important aspect when it comes to testing is fast feedback. What do I mean by that? So if I write a new piece of code, for example, then I want to get very fast feedback if the code I wrote actually does what I expect it to do. Or if I'm refactoring something, I want to have very fast feedback loops to know if I broke something or if everything still is working as I expect it to work. The second point is, I think, probably the most obvious one. We want to get confidence from our tests. So we want to be confident then whenever we deploy something new to our production system, that everything still works. That's probably why we test in the first place, I guess. And the third aspect, I think, is often overlooked. And that one is flexibility. What do I mean by flexibility? There are actually two things I mean by that. First of all, as we saw on the previous slide, there are a lot of tools for testing. And we want to have the flexibility that whenever a new and better and faster tool comes up, like recently Vitest, for example, that we can switch to a new tool without rewriting maybe hundreds or maybe even thousands of tests. And the second important aspect of being flexible is that we are able to use the best tool regarding the outcome we want to achieve. So when we want to have very fast feedback, we want to use a very fast tool. And when we want to have confidence that our tool works in a particular browser, we want to use a tool that can run our tests in this browser. Okay, so I want to tell a story about two teams. The first team, let's call it team end-to-end testing, uses mostly Cypress for running their tests. So Cypress is an end-to-end testing tool where we can run our application in a real browser and test the application like a real user would use our application. So this gives us a lot of confidence. The second team, let's call it team component testing, They're using Vitest. So Vitest, for those of you who don't know, is a unit testing tool, which basically is like Jest, but better and faster. And for those of you who don't know Jest, Jest is a unit testing tool, so you can use it to test Vue components, but also JavaScript functions and stuff like that. So team component testing uses Vitest, and they test components in isolation opposed to the whole application. But let's start with team end-to-end testing. So team end-to-end testing, as I said, they're using Cypress, and with Cypress, they can run the whole application in a real browser, and so they have a lot of confidence because they test their application in a real environment and exactly how a real user would use the application. So a typical test they write would look something like this. So they have a description. In this case, it should be possible to add a new item to a list. So what we are testing here, we see this in the demo, after that code piece, is a shopping list application where we can add new items to our shopping list. So if we want to go shopping and we want to buy butter, for example, then we add butter and then we have it in the list. Then we can click it and then we crossed it out from the list, basically. So it should be possible to add a new item to our shopping list. And for this, we first visit a page because team end-to-end testing runs their tests in Cypress, and Cypress starts a real browser, and in the browser we can visit a particular page. And in this case, the shopping list is located on the home page, so we visit the home page and open that in the browser. And then we can find an input field in this example. So in this here, we look for an input field with the label title, and we type some text, in this case, just foobar, for example. So we have an input field with some text in it. Next, we use Cypress to find a button element with the name of add item. So in our application, we have a button for adding a new item, and we locate this using Cypress, and we click this button. And after we have clicked this button, we expect that this item should be added to our shopping list. So let's take a look at the demo. Let's see. Now you can't hear me. So I have to do this one-handed, I guess. Hello. Oh, that would be great. No, no problem.
I'm not in the way.
So, thank you, Jess. Sorry for that.
Okay.
Okay, so here we see Cypress, and what we already can see is that it has an awesome user interface. So, on the right, real quick, I show you this very, very simple shopping list application. So, there is already an item in our shopping list, and there's also a recently used item. And if we want to, we can add a new item. So I like butter, so we add butter. And then we have butter in our shopping list. And when we are in the shop and we actually put it in our bag, we can click butter and it's removed. Sorry.
He's going to make it properly. Fun fact, we rewrote Cypress in Vue last year. So it's all Vue 3, wrapping a React command log right there. So what you're staring at is a micro front end inside of Vue, if you're ever wondering on how to transition your application. All right.
Okay.
You good?
Yeah, I think that's better now. Is it?
Perfect.
Yeah. Okay, so if I'm not, I was already nervous enough, but having Jess actually besides me, watching me, okay, so okay, so I demonstrated this very, very simple application, and as you can see here, the tests already ran, but we can run them again to see it actually works very, very quick. So we have 5 tests here. Let's focus on the one we just saw the code for. and this is the one for should be possible to add a new item to our shopping list. So we can click on this test, and here we can hover over all the steps. And this is very, very useful for debugging, for example, if some test doesn't work, or even when we work on new tests, it's very, very useful to actually see, and by hovering, we can reproduce the single steps that Cypress is doing for us. So we visit the home page, then the application loads, and here we see this find by label text command where we find the input field, and we see Cypress is able to find it, so it's highlighted here on the right. Then we enter some text. We can see here foobar is entered. And then we find the button by role, so we find an element with the role button. This is for accessibility reasons, so to make sure that we're actually using the correct HTML elements. And as we can see again, Cypress is able to find this button, and then we click it, and we can actually see where Cypress is clicking. This is very, very useful in cases if you have modals, for example, in your application, and you can and some test breaks unexpectedly, then oftentimes it's because some element lies above the element you want to click. And with this visual feedback that Cypress provides, it's very, very easy to see what actually goes on. Okay, and the last step is we're making sure that the new item was successfully added to the list, and with that, the test succeeds. Okay, so much for the Cypress demo. And team end-to-end testing is working on the application, and they are writing a lot of tests. And in the start, they are very, very happy because they have high confidence in the tests because they run in a real browser. And as long as there are not too many tests, they are also reasonably fast. And debugging is easy, everything is awesome. But, so the application is growing, and as they should, they are writing a lot of tests, like in this case, 1,540 tests. And at this point, I have to make a confession. So at the start of the talk, I didn't really finish something up. You might have already guessed it. But actually, I'm in team end-to-end testing. And the tests you see here running are actually those 1,540 tests. And as you can already see, it takes a time. So I can spoil it a little bit. It will take actually like 35, maybe 40 minutes. So even after I finish the talk, they will not be finished yet. So that's a problem, because as I said in the beginning, I think for me, the most important aspect of having tests in place is the fast feedback you get from them. So you want to be sure that whenever you make a change, you want to have the fast feedback that whatever you did didn't break anything that you didn't expect it to break. And like 30 minutes, I mean, actually for this many tests, it's even not too bad, I think, to wait 30 minutes, but still, it's too long. So that's where we stand with team end-to-end testing at this point. We have this fantastic UI, so we can easily debug if something goes wrong or if some test is flaky. We get the high confidence because we run the test in a real browser and we're testing our whole application and not only parts of it. But feedback, unfortunately, gets slower and slower the bigger and more complex our application gets. So let's take a look how team component testing is doing in the meantime. So team component testing, as I said at the beginning, is using Vitest. And the special thing about Vitest, especially when we compare it to Cypress, is that we don't run our tests in a real browser, but the tests run in a node environment. And this is much, much faster, because although we're pretty much using the same JavaScript engine, starting a browser and also the overhead of the DOM itself adds a lot of time to the runtime of tests. So let's see how a typical test looks that is written by team component testing. Again, we have basically the same, a test testing the same functionality. We want to test if it's possible to add an item to our shopping list. But the main difference here is we don't render or we don't open the whole application, but we render a single component. So we test this single component in isolation. But the other steps are pretty similar, just the syntax is a little bit different. So here we see we again find an input field with the label title, and we enter some text. And again, we click the button, the add item button. And also, last but not least, we look for the text to be successfully rendered again in our shopping list. So similar, but as I said, most important difference, we don't run our whole application, but a single component. We test a single component in isolation, and the syntax is different, but much, much, much faster. So by running our tests in Node.js, we're actually able to run like thousands or hundreds of tests in seconds, actually, and not minutes. But team component testing is working on the application as team end-to-end testing, and in their case, the tests are very, very fast, although they have a lot of them. So they add tests for all of their components. They are very proud because they have 100% line coverage of all of their components. And still, from time to time, bugs escape into production, and they start to wonder. We're doing everything right. We write a lot of tests. We have a high coverage, high code coverage. Shouldn't the tests prevent bugs escaping into production? And their answer is yes and no. But in this case, mostly no. Because the problem here is that, first of all, by testing, we never can prevent all of the tests, all of the bugs to happen. Some bugs will still happen because we don't know everything beforehand. But there are other things that come from only testing components in isolation. So in this example, we have a parent component which is listening for a created event emitted by a child component. And then we have a child component emitting a create event. Can somebody already spot the problem here, maybe? Exactly. Thank you, Jess. So we are emitting a create event, but we are listening for a create that event. And this is one example for, even though we might have very high coverage and we might have tests for all of our components, bugs like this might still happen because we don't test this particular event in our component tests. But there are other things that can happen too. This is just one example. And the second thing they discover is that again and again they have problems with false negatives. So what do I mean by false negatives? Imagine one of our tests is flaky and doesn't work correctly, but when you're opening your application in the browser and actually test the feature manually, it works. So you wonder, why doesn't it work in my test? It should work, because when I do it manually, it doesn't. It does work. So the answer is there are many reasons for this, why this happens. Mostly it's race conditions, for example, or maybe you have the same selector 2 times and you're expecting to click on the first button, but the second button has the same selector, or you're expecting to click on the second button, but the first button has the same selector, and what your test really does is clicking on this first button, and so it doesn't work. But the problem here is, because you don't have the visual feedback that we saw in Cypress, where we actually see where we click, it's very hard to debug such false positives because we just can't see what is happening. So this is where team component testing stands after building their big application. They have blazing fast feedback, or let's say turbo fast feedback, I guess. It's an insider. But there are unexpected bugs and false negatives. So they are also not very happy. Although everything is very, very fast, they get very fast feedback, but they think, yeah, as long as we can't prevent bugs from escaping into a production environment, what is really the point? So they are kind of disappointed as well. So there are many solutions to this, and there is a whole talk about how we can solve it, a whole other talk about this. But what I want to focus on is how we can utilize the best tool for the job so we can get the best of both worlds. So how can we use Vitest when we are after the fast feedback, and how can we use Cypress when we want to have the great user interface and when we need the visual feedback, for example, for debugging. So what if I tell you that it's possible to run the same 1,540 tests that are still running here in like 20 seconds? Spoiler, sorry. So it's possible. Like, let's just do it. I have this npm script here. Oh, npm run, like that. So, now. Okay, so we'll take a couple of seconds, but not too many actually. So just like that. And we're done. Okay, that were like 70 seconds, and you have to remember that we are still running Cypress in the other tab. So actually, if you don't, maybe you saw the spoiler if you look very quickly. If you don't run Cypress, you can finish the tests in like 14 seconds. So that's a lot faster. And probably when looking at CLI output, it's not very clear maybe, but we are actually running the exact same tests. So you can see here, we have like this benchmark 7 file, for example, and here, if we take a look, here we have the benchmark 24 file. So those are the exact same test files we are running here. But in this tab, we are running them in Cypress in a real browser. And here we are running them in Vitest in a node environment with a mocked DOM environment. So now I want you to imagine the possibilities this would open for you. So imagine you're having a really big application where it's really hard to make changes. But now imagine you have perfect test coverage, at least for the most important features. So when I'm talking about test coverage, I'm not talking about line coverage, because that can be very, very misleading. I'm talking about feature coverage. So imagine you have a lot of tests that test all of your most important features at least, or all of the features if they break, you want to fix in a couple of minutes or hours. So what this enables you is to make changes with confidence. So whenever you want to refactor something, for example, because you're unhappy with some design choice you made or something like that, you can just change it, and you can run your tests in a couple of seconds and can be sure that everything important still works. But I just let you read what Marvin Hagemeister posted a couple of weeks ago. He's one of the maintainers of Preact. So there are two aspects I want to highlight here. So the first one is, he writes, it makes it much more enjoyable to try out new ideas. So isn't this what we really want? We want to enjoy working on our code, and isn't this what so often is not true with our very big projects and legacy projects? And the second thing he writes is, he's glad that they invested early into a fast test setup. So it's definitely an investment you make, but I think, or in my experience and in his experience obviously, it pays off great dividends if you do that. But now you might wonder, how can we do that? And the answer is, as so often, we can achieve this by building bridges. And this is like, there is a bridge pattern in programming which we can use to achieve this. And by this I mean the bridge pattern means we have our tests on the one side, and we have test frameworks, or at least one test framework on the other side, and between those two we want to build a bridge, or we want to implement a piece of code that bridges the gap between those two. So here we can see a driver interface. So the bridge is a test driver in our case. And the test driver specifies the methods we saw in the previous tests. We have a find by label text method, we have a find by role method, we have a find by text method, and we have a go-to method, which will be the most interesting one, I guess. And here we see a particular implementation. In this case, this is the Cypress driver implementation. I have to say that this is a very, very simplified version. So the real implementation, there will be a link at the end to the GitHub repo, is a little bit more complex, but I think this sells the point very well. So here we have a Cypress driver implementing this test driver interface, so that is, or this test driver type. And here we have all the methods, like first the find by label text method, where we use the Cypress find by label text method. Find by role, we use the Cypress find by role. Find by text, we use the Cypress find by text. And go-to, in this case, is just a wrapper around Cypress visit for opening a new page in the browser. And now, I think, now it gets most interesting with the Vitest driver implementation. Again, we have Vitest driver implementing the test driver type. Again, we have a find by label text method. In this case, we're using the testing library to select DOM elements. So we have the screen find by label text, find by role, we have screen find by role. This works now in the mocked DOM, not in the real browser. Find by text, and now the go-to method, the most important part. So instead of opening a real browser window, which we can't do because we are in a node environment and there is no such thing as a browser window, we use the fact that our application relies on vue router. So vue router abstracts all those routing concerns away from us, so we can use it in our tests. So instead of opening this particular URL in the real browser, we can just push the path into the vue router, and after that, we render the whole application. So instead of rendering a single component, we actually can render the whole application. And when we push the correct path into the router beforehand, it will render the correct page component, for example. And for testing purposes, it's basically pretty much the same as if we would render our application in a real browser. So when we take a look at a test that is implemented with this driver pattern in mind, again, first we specify the description. So we want to test if it's possible to add a new item to our shopping list. But one important change you can see here is that we inject a driver into our test callback function. And this driver can now be the Vitest driver or the Cypress driver. But our test doesn't care at all, because our test only cares about the interface of the driver. So as long as the interface matches, our test doesn't care. So then we can use driver go-to, and if we pass in the Cypress driver, then we will open a browser and visit the page in a real browser window. But if we run the same test using Vitest, we will just push the path into the router, so telling the router which page component later should be loaded, and then render the whole app component. And then we can, like we saw in the previous test, find the input field, enter some text, find the button, click the button, and make sure that the item was successfully added to our shopping list. And by doing that, we basically have it all. Because now we get blazing fast feedback. When we want to make sure that after a big refactoring, for example, we want to be sure that everything still works as we expect it to work, we can just run our tests in Vitest. And in a matter of seconds, we know if everything still works correctly. But if we have problems with a flaky test, or if we need to debug something, or if we want to write a new test, then the user interface of Cypress comes in handy. And we can just run our tests in Cypress and get the benefits of the great user interface. And again a spoiler, sorry. And we also get the high confidence by being able to run our tests in different browsers. So with Cypress, we can run our tests in Edge, we can run our tests in Firefox, and I think there is some work done that we also can run our tests in Safari at some point. But there is one more thing. So that was actually Tim, who unfortunately caught COVID, who inspired me to do this. Oh, they finished, sorry. Oh no, that's the wrong part. Yeah, they're still running. No, good. So, okay, so what we can do now, we not only can run our tests in Cypress and Vitest, we can run the same tests in, I can't speak and write at the same time. We can run the same tests in Playwright as well, just by that, by executing this command. And now we are running the tests with a Playwright driver. And I will let them run. Again, I can spoiler, it will take something like 3 minutes. So it's also a lot faster than Cypress, because with Playwright we are able to run our tests in parallel locally as well. With Cypress, this is only possible, as far as I understand, with the Cypress Cloud service. So I just leave them running, but in the meantime, we'll finish the talk, and maybe after the questions, we can see the final result. So now our two teams can switch to this new approach. They can use the driver pattern, and hopefully all their worries are gone, and they live happily ever after. My name is Markus Oberlehner. You can check out my stuff on Twitter if you're still into Twitter. I'm also writing a book about testing. Currently, it's a paid newsletter. You can check it out at goodviewtest.com, and if you subscribe, you will get a free ebook whenever it's done, and it's done when it's done. And you can check out the code in this GitHub repo, and if you don't want to type it, you can scan the QR code, and it will lead you to this slide, actually. It was great to be here in Toronto. It was a pleasure to speak in front of you.
I was too busy clapping to remember to come up on stage. Hello, that was lovely. That was awesome. Thank you.
Thank you very much.
Oh, all right, does anybody have questions? One. Yes, lots of questions.
Hello. Oh, sick. That was a great talk. Thank you very much. You mentioned two teams, an end-to-end team and a unit test team. Assuming there's like multiple people, maybe on both teams, what if the team consisted of one person? Do you think it's possible to take this on, and how would you approach that as one person and then maybe growing the team from there?
Sorry, can you say again? There's one team do you have two separate teams for testing? Did I understand this correctly?
Yeah, sorry, just to like go back to your talk, like you were talking about like the end-to-end team, like this hypothetical side, right? Yeah. And the hypothetical unit test team. Yeah. Really what I'm asking is just how would you kick this off as like a single developer? Yeah.
I think the team names were kind of misleading. What I meant was that the team, there are all developers and they're writing their own tests, and the one team uses end-to-end tests to test the application and the other unit tests. But in general, this talk was a little bit of a simplification. So usually you want to have both. You want to have end-to-end tests, and you want to have unit tests. But the point I wanted to make is that it's not so much a division between tools, so that you use Vitest only for component tests and unit tests, and Cypress only for the others, but that you actually can use whatever tool is better at what you are after right now. So if you want to have the fast feedback, you can just quickly run them in Vitest. But if you want to really be sure that your application works in every browser, or if you want the visual feedback, you can run them in the other tool as well. But to answer the question maybe between how do you decide when to write end-to-end tests and when to write unit tests, I think this is a talk of itself. I have the talk in mind, so maybe in a future talk I can answer this in detail.
Hi.
Question? Oh,
Over here. So you showed the benefits of running the tests in like a headless environment. Is it possible at any point, like in the midpoint of a test, let's say, to then render the application in a browser window, like if you need to grab a screenshot of a specific state?
Mm-hmm. Yeah, I think the idea is you can run all the tests. You can run all the tests in Vitest, and then you see one test is breaking, for example, and then you can run this single test in Cypress, for example.
So is it possible to like render it in a browser window and then resume the test like part way?
You have to do it manually, so there is no way to switch between them. But if you see one test failing, you can just pick this one test and then start Cypress and take a look at this one test in Cypress.
Cool. Thank you.
mm-hmm. Question in the middle.
Here, if you can see me.
And then there's somebody over there.
On your left, on your center, here. So you basically blow my mind a little during this talk. I'm a bit confused. So if I understand well, you mix the Cypress tests and the unit tests into one, but by creating this driver abstraction, you just, when you run the Vitest, you just bypass all the go-to things that you have normally in the browser, no?
So I didn't really mix component or unit and end-to-end tests, but just switched up the test runner, basically. So instead of running, it's still like, I mean, it's a little bit confusing because the both examples were on purpose pretty similar, because usually, if you write a component test, you maybe write a component test for a smaller component, and in this case, I wrote a component test for a very big component, so the tests were basically the same, but this was kind of per accident, or it was kind of to better demonstrate the similarities or the differences. But in a real project, you would have, the tests would look rather different. Like you have, your end-to-end tests would be a lot different than the component tests in most cases.
Because my question is, okay, so you have your go-to, etc., that is based on Cypress, and you run in your pipeline the Vitest test. Mm-hmm. How can you rely on those tests if you have two projects, two teams working on the same testing projects? One is writing the Cypress test, and the other one writing the Jest?
Yeah. Again, this was a little bit confusing, probably choosing the names. So what I meant by the names was that this team, this is a development team which have testers or QA persons and developers or only developers. The point was just that they are chosen the approach only going for end-to-end tests, and the other team choose those are not two teams who work on the same project, but two teams, two imaginary teams who have different approaches to testing. So I would not recommend to have two different teams doing different kind of tests. I would always recommend that, I'm even of the opinion that you shouldn't have separate QA roles, but that developers should write all the tests, also the end-to-end tests. I mean, that's probably kind of controversial because I know it, at least from my company, we have separate roles, but personally I think maybe you can have QA persons who are a support role, who work like in pair programming mode with developers to write end-to-end tests, or developers do it all by themselves, writing unit tests and end-to-end tests. I would recommend that.
I don't want to take more time, but I will have more questions. Because for me, in the CI/CD pipeline, I have many questions about all you present here.
Okay, we can talk later.
Thank you so much.
Oh, you already have a microphone. Please.
Thank you so much. Definitely very impressive performance improvements there. And I'm just curious about the go-to method and how that's implemented. It looked like it was kind of doing some replacement of the normal routing and then reloading the app. So my specific question is, in a case where you're trying to get through a flow for the end-to-end test and you're going like on a form from like step 1 to step 2 to step 3, and then It's like it's been submitted, you have your confirmation step. So in that case, is it able to, when you're routing from like step 1 to step 2, is it going through the go-to method? Like, again, is it reloading your app and losing the state from the step 2? And then if you have route guarding on step 2 where your app doesn't allow entry into step 2 directly, like how does that work for like larger flows?
So if I understand it correctly, it's about the routing stuff. So the go-to method is only called if in your test you visit a new page. Then you call the go-to, and then the router push is called. If you click on a link in your test, or if you submit the form, then as long as you use the view router routing, it will just work basically the same. So it really doesn't make any difference if you run them in this Vitest environment or in Cypress, because the view router works perfectly fine in the Node environment as well.
Okay. Thank you.
You implemented a driver, which is basically a bridge between two test runner, right?
Yeah.
What if you have a lot of custom commands? You know, Cypress has custom commands, so you could write custom functions.
Yeah.
If you have an existing app which has a lot of custom commands, I believe you will have to replicate the same on the Vitest side.
Yeah. Yeah, it depends on the commands you have. But if you have a very complex test setup, doing this after the fact will probably be very hard. Also, there are use cases where it's also not even possible. So if you, for example, if you test something with iframes, or you test something switching between tabs or something like that, this won't work in Vitest. If you have a lot, I mean, usually this shouldn't be too much. It depends on your application, obviously. So there are applications which depend heavily on a lot of iframes and do a lot of cross-tab stuff, then this is probably not for you. But other than that, you probably need, if you have like one instance where you have to switch tabs or something like that, you probably need to implement something that you can skip a particular test in a particular driver. So for example, in the Vitest driver, you don't do the tab test, for example.
So one last question is there any open source driver or a bridge that takes care of the default function?
I get this question, I get all the time actually. and all the time is, my answer is twofold. First of all, I'm lazy and I don't want to maintain such an open source project, so I won't build it. If anybody wants to build it, then you can look at my code, you can do it, no problem. But the second answer is, I don't know if it really makes sense, because this driver is also an opportunity to simplify the testing API for your use case. So if you think about Cypress and Vitest, those are amazing tools that enable everything you can think of. So every test case you can think of, it's possible to do, or almost all of them you can do with them. But that's probably not necessary for your application, so it makes it only more complicated. So I think there is an opportunity to simplify the API, and that's why I don't recommend to make a generic driver, because then you need to implement all of the APIs as well. And I think that's not, I think that's missing an opportunity for simplifying it for exactly your use case.
Okay. Thank you.
We have time for one more question.
I'm here.
Okay.
Great talk here.
Let's do it.
In the middle.
Yeah.
Thank you very much. It was a great talk.
Good.
My question is that with Cypress's upcoming component testing, that's going to run on a dev server and isolation, do you think that, does it equal the benefit of using the Vitest, or what's your suggestion, moving from Cypress to Vitest, having both of them, or just sticking to the Cypress until it comes out?
So if you already have Cypress tests, oh, sorry. I still can't see you. I think, no, yeah, you are actually exactly beneath the light. If you already have Cypress tests, you said, if you should, can you repeat it? Sorry.
It's on. With Cypress's component testing coming up, do you think that
Yeah, sorry. You know, I
Should
was,
she migrate?
yeah, before I was confused because I was looking for you. So, okay, with component testing, the thing is, I tried to make it also work for component testing. So basically, you can do your component tests also in Vitest and in Cypress. The thing is, and I already talked about this with you.
Did you text me about
Twitter.
this on Twitter?
Yeah, yeah.
Oh,
It's about the,
okay.
no, it's about async await, the lack of support for async await. So
The top level.
the problem with making a driver for component testing. So I wanted to build a driver for component testing as well. So you have a driver to run your component tests in Cypress and in Vitest. But that's harder to do because Cypress doesn't support async await, and so the APIs would look very different, and it would not be very useful for component testing, I think. So that's why I didn't do it. But the second thing that's in your question is, is it even necessary to use two tools when Cypress can do both? Like Cypress, also for component testing, is a lot slower than Vitest because it's not a bad thing, it's just the trade-off, you know. If you run the tests in a real browser, it will always be slower than if you run them in Node.js, but you get the benefits of the real browser. So if for you it isn't important how fast they are, or they are fast enough, then you might choose to only use Cypress because it's a lot simpler to only have one tool. But if it's a problem for you that the runtimes, the test runtimes get longer and longer, you might decide to do something like that.
I would say that async await support is Cypress has their own promise chainables, and writing isomorphic code that supports await next tick is not going to work. So writing an isomorphic test that works in both would be very difficult.
Yeah.
Yeah.